Hi everyone, welcome to the Advanced Structural Analysis lecture series. In the present topic, we will discuss the analysis of a plane truss, that means finding the member forces using stiffness matrix method. So let us look at a truss example, the pin jointed plane truss by stiffness matrix method. And here we assume all the members have an area of 1 millimeter square and Young's modulus of 200 GPa. So this is a truss, 3 bar truss with forces at joint B and joint C. So the important thing here, as method goes, we need to identify the degrees of freedom at a joint. So now at a joint, we know in the truss, plane truss, in plane truss, that means 2D truss, each joint has possibly 2 degrees of freedom possible, but out of that, how many constraint you have to see? Here a joint is constrained because hinge is there, so it cannot allow any degree of freedom. So here is 0 degree of freedom. At B, there is no hinge, any support at the B, so there are 2 degrees of freedom. At C, vertical is constrained, so degree of freedom horizontally, roller is there, so possible, so 1 degree of freedom. So total for this truss, the total degree of freedom is 3. So now I need to write down the degree of freedom, or I can also coordinate at the now I will mark here the degree of freedom. So I will take this will be my 1 degree, here will be the 2nd degree, and this will be the 3rd degree. This is my coordinate marking. So these are coordinate markings. Very important to do the coordinate marking, otherwise the entire problem can go wrong or the examiner cannot understand without marking the coordinates. Now it's very important. Now we should also try to get the angle, because in this diagram the BC length is given as 300 millimeter and AB given as 400 millimeter. So by the calculation, because this is being a right angle, so this will be a 500 millimeter. So this angle will be is 53 degrees. This is important to note it. So here angle is 53 degrees. So since I have 3 coordinates, so I will have the stiffness matrix of 3 by 3. So now let us look at stiffness matrix for each of that. Like let us say K11, K21, K31. Like this we can work out this stiffness matrix. So I'll write here the stiffness matrix K will be of size d by 3 because I have 3 coordinates. So what will be the K11 element of this? So K11, that means in the coordinate direction 1, when I apply unit displacement here, what will be force produced there? And in the previous class we also learned in the same direction we have a cos square theta, which is in the x direction. In the x direction cos square theta, and y direction we have sine square theta, right? So if the coordinates are having the opposite direction, means perpendicular directions, then we have a sine theta cos theta. Along with that, AE by L is always a common. So you can remember this much. You can say xy. If there is any combination of xy, sine theta cos theta, right? Horizontal direction, cos square theta. Vertical direction, sine square theta. If combination is there, sine theta cos theta. It's very important. So with that, and at the joint, same joint, you can add summation. Okay. So let us say K11. So K11, that means at the joint 1, how many members meeting? 2 joint meeting. So K11. So summation of A by L for the member CB and member CA, right? Member CB and member CA. So member CB, which is AE by L, that means A into E we can calculate. AE is 1 into 2, that is in Newton per millimeter square, 2 into 10 power of 5 Newton per millimeter square. So this is millimeter square. So this is 2 into 10 power 5 Newton A into A axial, right? Newton per millimeter square Newton. That's what. Now AE by L. So 2 into 10 power of 5 AE by L of that member, which is 300 into 1. So same horizontal direction, cos square. What is the theta? From the positive x-axis at that joint, what is the angle of that member for which I am finding? That is BC member angle with respect to the positive x-axis there. So this is 90 degrees. Now this for one member. There is another member also. So CA is there. So plus AE by L. So 2 into 10 power 5 by L for this member is 500 millimeter. This was 400 millimeter. By length is 500 into cos square. What is angle of this member from this positive x-axis of the coordinate here? This angle previously was 90. So this is 90 plus 53, 143. Okay, this is very important. 143. So when you calculate this, cos square 90 anyway 0, cos 90 0. So this you can calculate this. So the K11 is equal to, let us say this the cos 90 0, so only this term left. So this value is equal to 255, right? This is stiffness, Newton per millimeter. So K21. Now see K21. So I have 1 here. Now 1 here and 2 here. Both are same x direction. So again cos square. Okay, cos square. Now 1 to 2 to 1. How many members are? Only 1 member will be there. That is why summation not required. And 1 to 2, since it is far end, effect of a 2, that will become far end, so minus. So we'll take a minus. AE by L, so 2 into 10 power of 5, length of that the member between 1 and 2 coordinate is this BC, length is 300, and since both same, so I have cos square. What is angle? So from this joint, I will consider C as a near end, B as a far end. So angle to the BC is 90 from the positive. So 90. Cos 90 0. So everything here equal to 0. So 3 1. Now 3 1. So unit displacement 1 force 3. So these two coordinates are perpendicular. So one is in x, second is in y. So when it's x and y, I should have sin theta cos theta. Since this 1 and 3 are different joints, summation not required. Because it being a far end, so minus. So minus 2 into 10 power of 5 by length of this member is 300 into 1 3 is two different coordinates like x and y. So sin theta cos theta. Right? What is the theta? The angle between this positive x-axis near end to the angle member, it is 90. So sin 90 into cos 90. So cos 90 0, so everything 0. Okay. So let us go to the next member and next stiffness. Again, I would like to draw here. If I draw here the coordinates, so here I have a coordinate of 1, this is coordinate 2, and this is coordinate 3. Here this is hinge, and there is a roller, and this angle is 53 degrees. This is 500 length, 300 millimeter length, and 400 millimeter length. A, B, C. Okay. Now, so let us take next K12 and K22, K32. So K12 is the, so now we are going for 2 1 is also equal to K21. So we already worked out K21, which is we got a 0 there. Now K22. So 2 2. Remember again, I will write the guideline criteria. If it is only x direction, cos square theta. If it is only in y direction, sin square theta. If the coordinate has one x, another y, sin theta, cos theta. This is very important. This is the guidelines. So now, if you see K22, 2 is x direction, right? Both are 2 2, so same x direction, cos square. So now AE by L, so AE 2 into 10 power of 5 by L is at the joint, two coordinate joint will have two members, so I have to take summation of both. Summation of both. So AE by L into 400 by 400 into cos square angle of that member AB from the positive x-axis. This angle, it is 180 plus. Now we also have a BC member joining from the joint B. Sorry, this is joint B, and this is coordinate 3. So 2 into 10 power of 5 by length of this member BC is 300 into sin same cos square. What is the angle of this member? Is this to this. Now I have to read from the positive x-axis till this angle. This is a 270. This was 180. So 270. So this is cos 180 minus 1 square, it is 1, right? 1. This is 270 is 0. So only this is 2 into 10 power 5 by 400. So I'll get a 500 Newton per millimeter. Now K32, 32, that means 1x 1y, so sin theta cos theta, and being the same joint, both coordinates are there, I can take a summation. So 2 into 10 power of 5 by 400 remains same, only angle will change, summation remains same. Sin 180 cos 180 plus 2 into 10 power of 5 by 300, you get the same thing here, A by L is the same, cos 270 into sin 270. Here sin 180 is 0, everything is 0, cos 270 is 0, everything is 0, so total 0. So this is 3, 2. So second coordinate over. Now let us go for the next coordinate, which is K13, K23, K33. So K13 equal to K31, which already we worked out as a 0. K23 is equal to K32, which already we got equal to 0. Now K33, look at the three coordinate, and there is a joint, there are two members meeting, and 3 is vertical y-axis, so sin square to be taken. So now since two members joining, so we will write down is 2 into 10 to the power of 5 by 400, that is this horizontal member, and there we have to take vertical member also. So what is the angle? The same angle which we just now you have seen here. Okay, into this is 3 vertical, so sin square 180 plus 2 into 10 to the power of 5 by 300 into sin square, angle of the next one is 270. So since sin 180 0, so this everything 0, sin 270 minus 1 square 1, so 2 into 10 power of 5 by 300, this term alone will give 666.67 Newton per millimeter. So once I found out the stiffness, I should also find out the load vector, which is P acting at the coordinate direction. So if you look at the truss again, so there is a load which is 500 Newton, which is inclined at 30 degrees. So this can be taken as vertical load as 500 sin 30, which is 250, and horizontal load as 500 cos 30, which is minus 400, means that is as a 433. Then I also have a force here as 2000 Newton, so all are Newtons. So here I have a 2000 Newtons. So now directly the coordinates, I have P1, which is my coordinate was the right hand side, but this force is opposite of that, so minus 2000, and second coordinate is my horizontal, so my force is a positive there, so 433, and third coordinate, the third force which is your downward, my coordinate is upward, so 250. So this is P1, P2 and P3. Now, so the stiffness matrix, the stiffness equation for the system is K assembled stiffness matrix into delta is equal to P. So now I have the K which is 255, 0, 0, so 0 and 500, 0, 0, 0, 666.67 into delta, which is delta 1, delta 2, delta 3, which is equal to P1, which is minus 2433 and 250, and 250 will be a minus here, and this will be minus because 250 is downward. So now taking inverse of this K, the delta 1, delta 2, delta 3 are nothing but, this inverse will give me 10 to the power of minus 4. If I take it common, we will have a 69.200, 39. 39.200, 0, 20, 0, 0, 0, 15, and multiplying with this load vector, which is 2000 and 433 and minus 250. So what I get is equal to, by multiplying this, so what I am getting is minus 0.784 and 0.866 and minus 0.375. Right? Now, once I get a displacement, I can find the member forces. So let us go to the member forces. Now we have a formula for member forces. For example, I'll draw the truss again here, small truss. Remember this, A, B and C. This was roller and this is hinge. Now I will also write down here the displacement, very important. The displacement obtained was here coordinate is 1, coordinate 2, coordinate 3. So minus 0.784, 0.866 minus 0.375 at 1 coordinate, 2 coordinate and 3 coordinate. This is important to know that. So now the PAB, let us say I want to find the member forces. PAC, so I will consider C to be a near joint, A is far joint. So as per the formula, we have AE by L into, I have displacement at far minus displacement at a near joint into cos theta, angle of that member. plus displacement in this is in x direction, displacement in y direction far minus displacement y direction near into sin theta. This is a formula, very important. We'll use that formula to find out the member forces. So the PAC AE by L for member AC, this is 500 AE. So 2 into 10 power of 5 is AE by this is 500 into far end displacement of A, that means A displacement both x and y is 0. So 0 minus x is near end because I am taking C is the near end. So x direction displacement at 1 minus 0.784. So minus 0.784 into cos, what is angle of that member from the horizontal positive x-axis, this is 143 degrees, plus y direction displacement in the far end 0 minus y direction displacement in near end here not there because y direction is restrained, so 0 into sine 143 degrees. And since this is everything 0, so this will get the 143, cos 143 is negative value. So this minus or minus plus. So this what we are going to get, this is minus or minus plus, this is total minus, so minus 250 Newton. Similarly, PBC 2 into 10 power of 5 by length of the member BC is 300, this was 400 by 300 into displacement BC, and again I will take C is a near joint, B is a far joint. Okay, x direction displacement far direction of far end, which is 2.866 minus displacement near joint in x direction, which is minus 0.784, total multiplied by cos of the member. So this near joint angle to this is this angle, which is 90. Previously was 143 degrees. So 90 degrees. Cos 90 plus what y displacement, vertical displacement far end 3 here minus 0.375, near end displacement not there, vertical displacement not there, so 0 into sine of 90. So this will give me, so cos 90 0, everything goes, sin 91, so minus value I will get a minus 250 Newton. Okay, now next last member, which is PAB, which is AB 400 length, so 2 into 10 power of 5 by 400 is the length. PAB, B I will consider as the near end, A is far end. It's your choice, not a problem. B is far end, near end, A is far end. So far end is 0 displacement. Okay, 0 minus near end horizontal displacement 2, which is 0.866. Okay, into cos, what is angle of this member from the positive x-axis of the near end, 180, right? This is 180 degrees. So cos 180 plus y direction displacement here far end 0 Y direction displacement in the near end B, this is 3 coordinate, so minus 0.375. This is total into sine 180. Sin 180 is 0, so cos 180 is minus 1, so minus minus plus, so I will get this as positive value as 433. So this is how I get. So minus means these two AC and AC and BC are under compression, and only AB under tension. So this is tensile force, this is compression force, this is compression force. So this is how we find out the member forces. Thank you.